In the previous lecture, we discussed about the rectilinear motion. Okay, and we saw for a first simple case, we saw one dimension along the x-axis. Put only one axis, and when the when the body or whatever is moving along the x-axis, then we define certain quantities. You remember displacement, path length, average velocity, average speed, instantaneous velocity, and the instantaneous speed. Okay, and then we saw about a uniform motion also. Uniform motion is what? When the body travels with a constant velocity, that is equal distance or equal displacement in an equal interval of time. Okay, so that's what you call as a uniform velocity. Non-uniform is non-equal distances. Non-equal distance. Okay, fine. So now we will see, in this lecture, we will see how we can represent, even though we saw some graphical representation we already discussed, we'll particularly see how all these motions can be seen in a graphical representation. Okay, for example, okay, let me plot the axis. This is a one dimension. Okay, so in a one dimension, what am I going to plot? You can ask why I have two axes in one dimension. Correct? Of course, I can have here as time, and this is a one dimension x. Correct? So this is a one dimension because moving in the x only, and time is another quantity. Okay, so normally we always think we all are living in the three dimensions, but actually we are not living in three dimensions. We all are living in four dimensions, because my hair gets grayer, right, with time. So that time is also one of a dimension here. Okay, so this is three dimension, four. This is so in a one dimension I can represent it as a time. I plot the time along the along this your usual x-axis. In the y-axis I plot the say your distance or whatever displacement or whatever the length from the origin. Okay, if you remember last time we plotted something like this. So from 0 it moves here, then goes back. I said like that. If you bounce the ball also, I do the examples. That length, that distance, I'm going to plot it along the y-axis. Okay, so you don't think this is x-axis. This is x-axis, not the x-axis one. Okay, and now there's the body, the ball. I'm holding the ball. Is the ball moving? Okay, and I'm holding the ball here. In the graphical, how will you represent? How it will be?
On the y-axis.
On the y-axis, what will be that? Tell me. Maybe the height is say something around say 1.5 meter.
1.5 meters from the origin.
Correct. So here, correct? So this is a one. Fine. So something. I call that as say some x1. Now, you want to represent this motion of the ball in the graphical. Is it moving? It is a stationary, right? How this will look here if you want to plot it with time. As it moves in time. Yes, it won't change. Am I right? So this is going to be a constant line. Am I right? So this is a body in rest. Okay. Suppose if I am asking you what is the velocity of this object now?
Velocity will be 0, right?
Correct. 0 for the straight line. Velocity and speed, they both are 0. Okay. And what is velocity? Nothing but the slope. Am I right? What is the slope of a line parallel to x-axis? 0. So it is 0. So what will be the instantaneous velocity? Say at certain time. Okay, I am going to plot an instantaneous velocity. I am asking you, I say some t0, what will be its instantaneous velocity? And what is the average velocity between t1 and t2? Can you tell me? What is the average velocity? You remember average velocity? What is the formula? V average, we wrote it as
t2 minus t1 divided by the
reverse. V average is equal to x2 minus x1 divided by t2 minus t1. Correct? Okay, so here what is your x1?
0.
x1. They both are same, na? What is this point? Tell me. This point is t2 comma x1. This point is t1 comma x1. Okay, and this will be t0 comma x1. So what is the velocity, average velocity here? Tell me.
0.
Yes, correct. This is 0. A straight line, right? What is the instantaneous velocity? What is the symbol for instantaneous velocity we wrote last time? You remember?
Limit time goes
Correct.
to 0.
That's okay. We wrote it as a v. Am I right? That is limit dt goes to 0. So we know dx by dt is a slope. Suppose if I had what is the instantaneous velocity at v0. So v at t0. That is what dx by dt at t equal to t0. Okay, that's what is the slope at this point, right? That's also what? 0.
Zero.
Correct. So in this case, your average velocity, instantaneous velocity, even the speed you say the all are the rest, everything will be same. Okay. Now I am asking you. Okay. So now, so let us take up another example. Okay. This duster is not good. Now I am giving you another example. So that is what? Another problem. Now, okay. So what am I going to give is, now I am going to move the ball above. So I am going to move the ball slowly up. Okay, or let us see you are tying a bucket of water in a rope and you are pulling it through the well. Am I right? The bucket will move up. Am I right? The water will move up. Okay, so if I am pulling such a way the movement, if it is a constant velocity means equal displacement distances or equal displacement with equal intervals of time. It is moving a constant velocity. How will you plot? Suppose that motion you want to plot graphically. How will you do that?
It will be a straight line from the origin to the.
Good. It will be a straight line from the origin. If you're coming from 0 to here, straight line origin. Okay. So then, that case, what happened? You're right. You got it, nah? Because what happened? It's equal distances. How do you actually do it is, okay. So why it got equal means you divide it into different time. Okay. So suppose if it is 1 second, it should have moved maybe something around in a okay, let us say 1 minute. It moved by say 1 meter or 10 meter, whatever. If it is a lazy guy, it will go for only 1 meter. Okay. And then in 2 minutes, it have moved by
2 meters.
2 meter, equal distance, equal intervals of time. And 3 minutes, it moved by 3 meters. So when you put up the points, these points all will fall on a what? Straight line. Am I right? So this will be a straight line. So this is what? This is what you call a uniform motion. Okay. So uniform motion. So let us try to do the what we saw, instantaneous velocity, average velocity for this. Okay, so let us take 2 times. Okay, I am going to remove this 1, 2, 3. So let us have. So then we will have 3 different points. So let be T1, let be T0, this be what you call T2. Okay. So at this place, this will be x1. Let me call it as x0. This will be x2. So what will be this point? T2. T2 comma x2. This point will be T0 x0. T0 comma x0. Okay. T1 comma x1. You shouldn't put x1 comma t1. Remember, because axis we change it. Okay. So fine. So now tell me, what is the instantaneous velocity between the time average velocity between the time t1 and t2. So v average, okay, between the time t1 and t2, let me call it as, okay, just raise it t1 and t2. So what this will be? So this is a vector first of all. I think earlier I forgot to put the arrow. Okay, so then what it will be? X2 minus x1 divided by t2 minus t1. Okay. What is that? That is nothing but what is the slope of a straight line? M equal to slope of a straight line joining between 2 points. You remember that? What is the formula? Your x-axis, y-axis, right? You have 2 points, x1 comma y1 and x2 comma y2. So this is what? The slope of the line? Or y2 minus y1 divided by x2 minus x1. Correct? Isn't the same thing? So this is a slope. Am I right? And we can write slope is nothing but dx by dt. It's a straight line. And dx by dt, because it's a straight line, dx by dt will be same. Okay, because this is a straight line. So of course the slope also will be same. Okay, so we don't write dx, let us write the final. So this is average velocity. Okay, and the instantaneous velocity will be what?
Be the same as
Average velocity. Yes, so v may be at t0. If I ask you to find out t0, that will be dx by dt at t equal to t0. And now since it's a straight line, so this slope is going to be same all the points. Am I right? So this will be equal to v average. Okay, so this example is what? You are pulling the water in the well, pulley. Now you pour the water back. Now we are going to drop back. Okay, now what happened? Initially the bucket was moving upwards. Now the bucket is going to move downwards. Okay, so
the y-axis to the x-axis.
yes, correct. So how this line will become? So in that case, the graphical representation will become correct. So then what happened? So now you already taken up, right? Now we are going to drop. You are starting from certain x, certain height. Am I right? And the height keeps decreasing, and you are moving in a constant velocity. That's what equal distance, equal interval. If you leave it, it will move accelerated. If you suppose you are dropping it slowly at a constant velocity, okay, then it will become at every second. It will now what happened? The distance will decrease. Am I right? So what happened? So maybe at 1 second. So let us say, for example, this is 10 meters or something like that. So a certain unit of time, let us call it 1 unit, it moves by 1. So at 1 unit, it moved down by 9. So it became 9 here. Am I right? And then 2, how it will go? Tell me? 8. Okay, so this is 8. So it goes on like that, right? So in that case, so it keeps falling. So this will be again a straight line because you are equal distances at the equal interval of time. So this is going to be a straight line again. Correct? So, and this is what we call as it's moving along the negative x. Got it? When x is decreasing. Okay, so this is what in this also. Again, you can do the same thing for your the slope also. Tell me. Okay. Now, can you tell me? Yeah, it's an interesting thing. What will be the average velocity for this?
Should be the same, right?
Yes, same. Can you tell me the sign of this velocity? This is positive, remember, because x is increasing, y is also increasing. Okay, so now let us see here. So what are the points here? Tell me. So let us call, okay, let me do it again. So let me take out the 3 points. Okay, so let me call this as T1 and let this as T2 and this as X1, sorry, T1, X1 and this will be T2, X2 and maybe at certain T0, we will have it as T0, X0. Can you tell me velocity is something but the slope? We saw that. Okay, so what it will be, tell me?
x2 minus x1 divided by
Yes, right, tell me. X2 minus X1 divided by T2 minus T1. Okay, now you tell me which is greater, X2 is greater or X1 is greater?
x1 is greater.
So what the sign of this will be? Negative. Okay, so this velocity is what? Negative velocity. When we wrote above, that's a positive velocity because this quantity is a negative quantity, right? Because X2 is smaller than X1. So this will be negative velocity, what you call a negative slope. If you find slope also, slope will come out to be negative. So this is a negative velocity. Opposite direction. Okay, so, okay, this is what they're shown in your 2 velocities. Okay, then we will have another one interesting motion. Okay, yeah. Now we'll put another question. Not this, we'll drop this well and the bucket of water, we will drop it. Okay, let it go to the well. Okay, I'm going to have a ball, rubber ball. I'm dropping it. What a rubber ball will do?
fall and it bounces.
It bounces back. And you want, now I am asking you, can you represent that motion in the graphically? Okay. So you understand? It's a what that will be. So now maybe you call this is negative velocity. It's going downwards. Then moves up, positive velocity. Then moves down, negative velocity. Well, if there is
Like
yeah, exactly. So then what it will be? Tell me, can you plot that one? T, this is x. Okay, so let us call, I'm going to start from here. First, what happened? It's going to fall down. Am I right? The distance is going to decrease with time. So it reaches here. Suppose this is the ground flow. Now what happened? It bounces back. Where it will go? It will go up. Within time, right? This time as it proceeds, now it go up. It reaches up to the height where it dropped. And then again it will go down. It won't go up, right? It will never reach above this line. So then it go down. And then go up, go down. You got it? So this is what we call as your, if a ball bounces, this is how the velocity plot. If you plot with respect to time, as the time goes, the x decreases and then decreases. But remember, I made it wrong here. What is the wrong here? You tell me. What I did here, it's wrong.
the speed will be, I mean, the waves.
No, it's correct. But what the straight line means what? Uniform velocity. Okay, but can a ball fall uniform velocity? There's acceleration due to gravity is there. Okay, so for time being, I take it simpler. Suppose you find there is no acceleration. Okay, there is no acceleration at all if the ball moves at a constant velocity and bounces back. Okay, so you will see in acceleration what happens, this becomes curved. Okay, so here it will become, it starts being, it will not be a straight line, we will see, non-uniform motion we will see. Okay, for time being, if it is uniformly moving down and coming up, moving down and coming up, okay, if there is no acceleration, this is how the pattern looks like. Okay, or another example for uniform oscillatory motion, you can, what else you can see, take anything in the horizontally moving forward and backward. So,
The yo-yo.
huh?
Yo-yo.
Yo-yo, I don't know, yo-yo you throw, no, yo-yo also has acceleration, it goes and stops and come back. Okay, so this is, okay, this is what. But actually here, it moves at a constant speed, stops here, and then moves here, something like that, okay. Because even whenever it stops here at this region, okay, it is not a constant motion. Because it changes the direction, velocity is changing the direction. Okay, so this is a simple representation, okay. So, object performing an oscillatory motion. They are written as oscillatory motion, but yes, this won't be a straight line because there can be acceleration. Okay, we will see that. So this is what, again also you can, the same thing at instantaneous velocity, you can find out all those things. I am leaving it. They also not given anything about it. So these are the main important things. You have to represent different motions. How will you represent it graphically? This is the way. Now, I give you another one. Suppose if the body's motion is not constant, means if velocity is not constant, that is, it's not traveling equal distance, equal displacement, equal interval of time, no, it is not valid anymore. Okay, in the earlier thing and all, you can always find out the speed also. Okay, what is the speed? Because if you take the magnitude of those velocities, average velocity and average speed, that is average velocity and the instantaneous velocity, that gives you an average speed or the instantaneous speed. I told you, remember? The magnitude of the velocity. Okay, that's the speed. Fine. In the last class we saw that. Okay, you can revise back. Okay, yeah. So now, if in the xt plot, if there is a motion of an object, okay, I'm giving a motion of an object which is not a straight line, which is a curve like this. Okay, so now, can you understand from this plot what's happening? As the time increases, what is happening? This is becoming steeper. Huh?
The speed is increasing.
Yes, it's increasing because now what I mean, take equal, simple. How do you find out? Is divide into equal intervals of time. Okay, or just find the slope of it. See here slope, because slope parallel to x-axis is 0. Slope parallel to y-axis is infinity. Okay, it's infinity. Okay, so the slope actually goes from 0 to infinity. Am I right? So now you see here slope. How the slope goes? The slope is increasing. Am I right? So therefore, what is the slope is nothing but the velocity. The velocity is increasing. Okay, so if the velocity is decreasing, how the plot looks like?
So the opposite type of curve. Right?
How? Think over. So the velocity, the car is coming fast and slowly it's puts off the brake. How the plot look like? Am I right? This is a slope here, no? So this is high velocity, it's a low velocity slope. Okay, so it doesn't matter. So for a time being, we will plot this one. We will take this one. Okay, so okay, now here what happened? We are going to give 3 different times. Say, okay, in your book they given 4 times, so let us say put up the same thing. T1, say some T2, then they have some T0, and then they have your T3 and T4. So correspondingly you have the points, right? Here it will be x, so I should write this one is what? X1, this will be X2, X0, this will be X3, yeah, and this is going to be X4. Can you tell me what's the average velocity between T1 and T4? Now remember. So now what is the average velocity? Now remember, now the velocities are not going to be same. Because the motion is not a uniform, this is a non-uniform motion. Okay, so then what happens? So if I ask you what is the average velocity between V average, I don't know, how do they represent here in your book V average between T2? They just wrote it like that, they didn't mention anything. Okay, between, let me call it as V average between T2, T1 and T4. So what it will be? Tell me.
You did it part by part, right?
No, I'm asking T1 and T4. T1 and T4, what is the average velocity?
X4 minus X1.
Correct, very good. X4 minus X1, that's a formula, right? This will be T4 minus T1. So now what this is, tell me? X4 minus X1 and T4 minus T1. So if you see, that is nothing but a straight line. The slope of a straight line joining these 2 points. The line is not coming out to be proper. Okay, so let me use this black color. Okay, so this is the slope of the straight line. So let me call it as AB. Am I right? This is nothing but the slope of the straight line AB. Okay, and similarly, can you tell me what is V average between T2 and T3?
X3 minus X2.
Correct. X3 minus X2 divided by T3 minus T2. So that will be another straight line joining between these 2 points. Do you expect the 2 straight line slope will be same?
No.
It won't be, not necessarily, right? Because it will be different. So therefore, this average velocity is going to be differ for different time intervals, because it's a non-uniform motion. Earlier it was same because for the uniform motion. Okay. So now, if I keep drawing, try to shrink this point, this 2 point T3 such that it approaches at T0. So then this is going to become a tangent. That is what? That's the instantaneous velocity. Okay. So the instantaneous velocity will be what? So V will be D at T0. Okay. Let me write it out like this. instantaneous velocity at time t equal to t0 will be dx by dt at t is equal to t0. What's the mistake I have written here?
Okay. X is a vector.
Yes, everywhere you have to mention. Okay, when in the no exam and all, never miss this arrow. Okay, these all are vector quantities when in velocity. Okay, so this is what I think that's all they mentioned about here. Huh? Okay, there is a one thing they written. This can be so the instantaneous velocity, average velocity between different points is going to be different when the motion is non-uniform. That's what you have to remember. Okay, and so the next. Now let us consider the case of first let us consider the case of a non-uniform motion. That is what it is not going to travel equal distances at equal interval of time. That's going to be different. So then you can define another quantity. Okay, so what's the one quantity we found initially is the velocity. Velocity is the distance traveled, the rate of change of distance traveled. Am I right? So now when I say non-uniform velocity, the velocity is going to change with time. Am I right? Because if you want to see here, you saw here itself, the velocity at different time is going to be different, right? Then we can define another quantity, the rate of change of velocity. Earlier we had a velocity. The velocity is the rate of change of displacement. The speed is rate of change of the path length, whatever. So similarly now I can know, where I can see from the non-uniform motion, okay, so this slope of the lines are going to be different. That means the velocity is not going to be constant. Velocity is going to change. Am I right? Then I can define another quantity and I call that quantity as what? You know that. Acceleration, right? Acceleration. And what is acceleration? Acceleration is the rate of, yes, rate of change of velocity. Okay, the same thing. Now, since earlier we discussed with the rate of change of distance, now we are going to speak about the rate of change of velocity because we saw the velocities keep changing. Am I right? So now, then you can define. So earlier what happened, when your rate of change of velocity is rate of change of displacement, then you define the average velocity, instantaneous velocity. Okay, the same way, here you can define average acceleration and the instantaneous acceleration. Okay, so let us write average, V average acceleration. Sorry. A average. Okay. A average acceleration. What it will be? Tell me.
Acceleration is per vector, right?
Yes, coming there. Very good. So VAVE will be x1 minus x2 divided by t1 minus t2. So similarly, average acceleration is v1 minus v2 divided by t1 minus t2. Okay, so from here, and of course this is going to be a vector. Okay, so from here what happened? The average acceleration is what? T1 and T2, right? Take the slope at T1, instantaneous slope at T1, that is the V1, instantaneous slope at T2, that's the V2. That V1 minus V2 by T1 by T2 is the average acceleration. Okay, and what will be the dimension of the average acceleration? Tell me.
L2 M1.
First, let us write a dimension of velocity. What will be? It is one.
L1 M0.
L1 M0 T minus 1. So now you know here. So what it will be? This is V by T.
So L1 M0 T minus 2.
L1 M0, very good. T minus 2. That's the dimension of your acceleration. Okay. And then, okay, this is the average acceleration between two times. Am I right? But remember, interestingly, this is V1 and V2, they will become the instantaneous velocity. Okay, when you want to define an average acceleration between two different times, that is the instantaneous velocity at T1 minus instant velocity at T2 divided by T1 minus T2. Okay, so similarly I can define an instantaneous acceleration also. Correct? So then I will call that as A, that will be what? If you remember, dV by dt. Okay, I think earlier I made a mistake. I wrote it as dx tends to 0. Am I right? No, that was wrong. I wrote.
You wrote dx tends to 0. Limit dx tends to
Yeah. No, that is wrong. So sorry, I made a mistake. Your v instantaneous acceleration will be limit. That's wrong. Yeah, okay, you're okay. Well, how do you do is, okay, actual thing is
time goes to
delta t or whatever. Yeah, time goes to 0. Am I right? Instantaneous velocity is, say, some t prime or t whatever it goes to 0, and this will be your, what will be, tell me?
x delta x by delta t. There will be x1
Not it. Then if you want to take delta t, then you try it as delta t. Delta t goes to 0. This will be delta x by delta t. And this we write it as dx by dt. I think I wrote it wrong earlier. Am I right? Delta x tends to 0 I wrote. Yeah, you could have corrected me there itself. Okay. Fine. So this is what? The same, so the same way we can write here. Am I right? So this will be what? So this will be limit delta t tends to 0, and here it will be what? There was delta x, right? This will be delta v by delta t, and this we write it as dv by dt. Okay, so there you have to correct when you are going for instant. Anyway, we saw it earlier class; it was okay, but in this class we just wrote it wrong. Okay, so this is what we the instantaneous acceleration. Okay. What else is there? Okay, good. So let us try to go again. We will see the graphical representation for acceleration. Okay, so let me say, for example, there we had a uniform motion. Uniform motion is for uniform velocity, or means velocity is always constant. And here it will be what happened? Uniform acceleration. Okay, so let us write. Okay, so now let us again, I am going to do the plotting again. Now what will be the axis? Tell me, what will be the axis for when I am going to deal with acceleration? What are supposed to be the axis?
Y-axis will be velocity.
Very good.
And x-axis will be time.
We are going to be time. Very good, correct. So let us draw the velocities. And so what we are going to do? We are going to have your x-axis is going to be time. In the y-axis, instead of displacement, we are going to have velocity. Now, so tell me. So there is a, okay, first we saw there's a body which is at rest. Okay. Now let us say there is a car or anything which is moving at a constant velocity. What the line will be here? Tell me.
It will be a straight line.
How?
Because the velocity is not changing.
Correct, velocity is not changing. So this is going to be maybe the velocity, say something around v1. This will be constant velocity. Now tell me, the car is at rest. What will be the line?
It will be the same.
Same? It will be v1?
No, it will be the origin.
Exactly. This is 0, na? If a car is at rest, okay, so this will be here along. This is 0, right? Velocity. So this will be the line. Along this axis is the for the car at rest in the VT plot. Okay, so that's something you have to remember. And this is a V1. And again, you can see here instantaneous velocity. The same thing what we are doing here, we can do it out. Okay, so instant velocity to be all the points will be means the instantaneous velocity will be same. Same as the instantaneous acceleration is going to be same as the average acceleration. Okay, and what else is there? Okay, now let us go for speeding up car. Constant acceleration. So how this curve looks like?
From the origin to the...
Yes, exactly. So in that case, this line will be from here. Am I right? And can you tell me, will the slope will be same at a point and 2 points and all? It will be same. Okay, again your uniform, for a uniform, this is what you call as a uniform acceleration. Because it's going to travel, the equal velocity at the equal interval of time. So that's going to be same. So this is going to be uniform acceleration. So the slope is also going to be same everywhere. Okay, so this is the case. Can you tell me this acceleration will be positive or negative?
It will be positive.
Correct, because it's increasing. The velocity is increasing with respect to time. Am I right? So that's why it's a positive. Suppose the car is stopping. The highly speeding car, it's coming and stopping at uniform acceleration. So this line will be
From V to T.
from like this? Correct. Because it's going to stop, right?
Huh.
So it goes like this and maybe stops here. Okay, and again you can define all your velocities, instantaneous velocities. Then you can find out your what do you call? What do you say that your instantaneous velocity, average velocity, everything you can find out. And now your integration comes into picture when you deal with your uniform acceleration or a typical acceleration. What is it? Suppose if this is the velocity curve, this is the trajectory, this is the velocity of the body which is moving. I am taking 2 points, T1, and let me say this is T2. Okay, let us go over the first case. That's the most simpler case. So that's for uniform velocity. You remember uniform velocity? What the line it will be? Straight line. Am I right? So I am going to take 2 times T1 and T2. Can you tell me what is the area?
T2 minus T1 multiplied by the height.
Height, yeah, this is 0, okay? So this is always you have to start with 0 in the case of velocities, okay? So this will be, so this height, let me call it as V, okay?
V into T2 minus T1.
So V into T2 minus T1, okay? And can you tell me, so this is a kind of an average velocity, right? Can you tell me the average velocity V is equal to what? x2 minus x1 divided by T2 minus T1. Can you see from here what is this will be?
Okay, T2 minus T1 will get cancelled.
No, what is it? V into, so this will become what? Take this here. So V into T2 minus T1 is nothing but x2 minus x1. Isn't that the area you found out? Okay, the area is what? Area is V into T2 minus T1. V into T2 minus T1 is what? x2 minus x1. That's what? Displacement.
Okay.
Am I right? So when you plot with respect to velocity and time, the area under the curve is going to give you the displacement. And how do you define area under the curve? You remember? A to B f of x dx. You remember the integration we saw? This is nothing but you plot f of x and the area under the curve. So area under the curve is nothing but here, in this case is going to be the displacement. Okay, the same thing we can do here also. So this also, what this will be for non-uniform velocity also. Okay, for this also it will be total displacement. Okay, here it is a uniform velocity. So for non-uniform velocity also, this area is nothing but the displacement. Okay, the displacement of the body within this time. Okay, that's how do you find, here it is simpler. You can take a triangle and this one, take the area under the curve, that's going to be the displacement. Okay, because you can, that I told you, from here also you can find out. If it is instantaneous velocity, V is equal to, this is VAV, sorry, I should have done. Okay, let me call this as VAV. Instantaneous velocity what? Dx by dt. Okay, so therefore dx is equal to what? V into dt. Am I right? So then if I integrate it, okay, certain time dt. Did I teach you this one? We taught you, na? I said the derivative and integration are opposite, anti-derivative.
Okay.
If you want to anti-derivative is what? That's what I am saying. V into dt between the time t1 to t2. That's going to give me x2 minus x1 displacement. Okay. So anyway, you will understand this more maybe in the 12th standard when you find. So what I want to say is this is nothing but the area. This is a v dt. Na? This is v and dt. This is a curve. Area under the curve. Okay. So area under the curve is nothing but the displacement of the body during that period. And what is left over? Yeah, then they have yeah, that's what they have written. Area equal to T2 V dt. Oh, correct. That's exactly what they have written it. Yeah. Okay. If you want to. Okay, and the same thing. Okay, I can do that. Then I will go for it. For a non-uniform acceleration. So this is for uniform acceleration. Earlier we get non-uniform motion. What happened? It was not a straight line. Get a curve, right? Again, here also you can have the same thing. Am I right? For non-uniform acceleration, it is not going to be a straight line. It goes like this, and then you can again define your average. Yeah, see, remember in other places, average acceleration, instant acceleration was same because they all are straight line, but it is not going to be. Okay, take these 2 points. So this slope is nothing but the average acceleration. Maybe at this point, the tangent is going to be the instantaneous acceleration. The slope is not going to be same. Am I right? The slope is acceleration. Are you sure about it? The slope in this curve is what? You should ask me, nah? Tell me. So, earlier also we wrote, right? What is it? For a constant acceleration, we draw the line like this. Am I right? So, let us take this point is what? T1 and this point is T2. Am I right? So, let this be V1 and this be V2. What is this point? T1 comma V1, T2 comma V2. Tell me what is the slope of the V2 minus V1 divided by T2 minus T1.
T2 minus T1. No, okay.
Correct na? T2 minus T1. What is that?
Okay, it will be average velocity.
Acceleration. So this is the slope. Am I right? The slope of the line is nothing but the average acceleration. Okay, in the earlier case, when the moment when you plot it x, that will be the slope of the graph when you plot between x versus t. The slope is average velocity. The velocity, not the slope is between 2 points, the velocity you get it. Here it becomes acceleration. You got it? So, and again also you can take out a point when it becomes, the instantaneous also at a, okay. Instantaneous acceleration is also the same as the say average acceleration, not velocity, average acceleration. What? Instantaneous, there are two quantities, na? Instantaneous acceleration and average acceleration. For a uniform acceleration, which is a straight line, your instantaneous acceleration same as the average acceleration. Am I right? You take the slope at any point, that's going to be same as slope calculated from 2 points. The moment when it is non-uniform acceleration, what do you mean by non-uniform acceleration? That means it's going to have a curve like this. In this case, slope will be for any 2 points. The average acceleration between 2 points, say T1 and T2, and maybe at a certain point T0, this is nothing but a slope at this point, right? Slope. The slope is going to be different from T1 slope. So here again, your average acceleration is not going to be same as your instantaneous acceleration because it's a non-uniform acceleration. What's happening? Okay, yeah. So then, okay, we're coming back to. So let us take for the case, for example, I remove this instantaneous acceleration here, and let me note it down this again. So, okay, and I'm going to take the area between these points under the curve. Correct? Okay. Area under the curve between the points T1, between the time T1 and T2. If you remember in your in the previous chapter, we studied about integration. Am I right? Calculus. So there we had a quantity. If you recollect back, what we did is, so if we have a function f of x or whatever like, so then this will be your a and this is b. Okay, so the area under this curve is given by a to b f of x dx. Remember, when this line becomes, when you try to get at a point, it becomes a slope. Differential calculus. Then we took the inverse anti-derivative. We first defined derivative, then we took the anti-derivative. Okay, and then we show there's something called the definite, that's what called as an integral. Then the definite integral and indefinite integral, right? So this is a definite integral. So whenever a definite integral, what a definite integral says is, it is nothing but the area under the curve between the points A and B. You remember? You go and revise back that one. Okay. So same way here. This is a uniform, non-uniform acceleration. Okay. So let us try to see. Okay. So what this will be? This is also curve. This is a function, right? V. So this equivalence will be what? V dt between the integral t1 to t2. Am I right? Correct? The same way we did. So now let us write. What is V? V is nothing but velocity, dx by dt. Right? V equal to dx by dt. V written there. Correct? These all are vectors. I am doing the mistake here. Okay, remember that. When you in the note, when you're writing the exam, you should never miss this arrow sign. Okay? If you miss the arrow sign, your mark will be cancelled. These all are okay, fine. Anyway. Fine, so this is V dt. So now V is what? So this will be t1 to t2 and V will be what? V is dx by dt into dt. So this is going to be t1 to t2. Okay. That's the reason I said don't cancel. So this is what happened. I'm not going to write the limit. So this will be what? So tt cancels. So this is going to become dx. Okay. So then what happens when you convert this into dx? So now the limits are in time, but your integration dx. Okay. So what you have to mention, what you have to write is when this t cancels and become x, this should become the x corresponding to t1 and the x corresponding to t2. So x corresponding to t1 is what? Sorry, the dx, not here this plot. So at t1, the x will be say something around x1. And t2, it will be x2. So now this is what? x2 minus x1. Okay, so that's what? That's nothing but a displacement. I mean, this is the vectors. Okay, this is nothing but the displacement. So area under the curve for non-uniform acceleration gives you the displacement. Okay, so that's what they have written. Correct. Yeah. So yeah, what they have written is in your book. What they have written is they have not written it as x1. What they have. Yeah, they also missed the arrow sign in your book. So what they have written is x at t1, x at t2. One and the same. Okay, so I wrote it as x1 or x2. So this is going to be what? X at t2 minus x at t1. Okay, so this is what your or everything about your acceleration and velocity and acceleration, rectilinear motion in one dimension when you're dealing with a one dimension. Okay, so you understood? Any doubt you have? Clear? Okay, so tomorrow we will see about the equations of motion. What you have studied earlier, we will try to derive those equations of motion. Okay, and then we will move to the motion in two planes. Okay? Okay, then we will stop here. Okay.